template. So let's say I always work in millimeters. I always want my grid to be this size or that size. You can save your own template. And you do that here, File, Save as Template. But let's go back to Rhinoceros Preferences. And let me show you a few things actually here. So we've gone through colors a little bit. So this is pretty self-explanatory. These are your viewport colors. This is how your objects display, etc. So you can change those how you want. So you can see I've sort of mucked around a little bit with my XYZ. I don't like this really bold colors as much. And my viewport background here is white, but you can adjust that a little bit, and your major and minor grid lines, etc. If you fool around with it too much and like, ugh, back to normal, just click on Restore Defaults. Then the other really interesting one is display modes. And here you can really dial in how you want things to look. And the one that I find really important is in shaded. And if you scroll down to shading settings, if you don't do anything, your setting is probably use front face settings for back face settings. So let's use that and see what happens. Let's just do this and let's do a quick simple extrusion. There's no difference between the front and the back settings. And if I click in direction, you'll see the outs, this is the outside, right? And if I flip it, nothing changes, it just looks the same. But now let's go back to our preferences, display modes, shaded, and instead of using front face settings, I'm going to choose a single color for my back faces, right? And now immediately you can see this is very helpful because now it's showing me that my direction indeed has flipped. And if I press flip, it's going to swap around. It's also helpful to see if your surfaces are open because you have this bright little green thing sticking out. You're like, oh, there's something, I need to close over there. So that's one thing that's going to help you prepare your files for 3D printing. The other thing that I haven't covered yet, but that we will do right now. So let's explode this. And I'm just going to move this face up a little. So obviously you can see now how the green already helps, right? Now I'm going to go to Analyze, Edge Tools, Show Edges. Analyze Edge Tools, Show Edges. And I will throw up a small tutorial just on fully preparing your files for 3D printing and how to check everything. But what this is going to do, so let's select this here. It's going to show me where if I click on all edges, it's going to show me all the edges of my surface. This is an edge, that's the seam, right? Here is another edge, and here is another edge. But what I really want is naked edges. And you see now it's just showing me this top one. And naked edges means that your surface is not closed. And that's a really good tool. And I can also say, let's say I'm out here and I can say, oh, I can't really see my naked edge. So I'm going to say zoom to the naked edge. And it's going to show me. Here's my naked edge. Now it's also showing me that this bottom one is a naked edge. And I believe that's because those aren't joined. But so let's join those. I'm going to join this and this. And now let's do our naked edge again. Show edges. So now you'll see it's only showing me the top one. So naked edges it's a great analysis so that you can know if your object is not closed or if your surfaces are not joined. And those are the things you want to make sure that are happening when you're trying to 3D print something. And sometimes when you're working with very organic forms, that can be hard to see, right? So let's look at Henry's file here. So first of all, you can see a lot of these directions are flipped, which should clue you in. Something's going on here. So I can either say flip. Okay, that's fine. And now let's actually, I'm just going to delete this one here so we can see. Let's do analyze, edge tools, show edges, select the surface for edge display. I'm going to choose this one. I'm going to say done and zoom. Aha, it's showing me where the naked edges are. And let's look. So I'm going to hide this. And indeed, I need to cap this. Now, I was able to cap it because this is planar, but if it weren't planar, so let's see. First thing I'm going to do is dupe edge. This is a good command too. I can duplicate the edge of the surface. And then I'm going to, let's see, how can I, let's do points on. I'm going to just move this so it's not planar, right? Because this happens often. You have something that's not planar, and so points off. Okay, now if I type in cap, it's not going to work. It'll have capped the bottom one because that one's planar. It's only on 2 axes. So this is where we're going to use our patch tool. So patch, and I'm going to go in and select my curves. And I can preview that, and you see it'll patch that up. And I say, okay. Now this patch is separate from this. So now I'm going to select that, select this, and type join.
Floor?
Yeah.
Does that work for like if I've lofted something and I couldn't cap it, or if I like did like network surf and I couldn't cap it?
It depends. You want to send me the file and we'll have a look?
Yeah, okay. Thank you.
Sure. So then, okay, so show. So let's say oops, join that again. Oops, I think I accidentally deleted a few things here. But if I want to 3D print this, I definitely want to make sure, or I don't know, maybe that's not true. Jake, this particular model, if these solids are not joined, and well, let's try it, right? So I'm just wondering if I don't join them, if Prusa is going to struggle with this. So actually,
I think there'll be separate shells in Prusa, but there'll still be one object, so it should all be together.
Still. Yeah, I was wondering about that as I was working on it.
Okay.
There's a way to like hit separate shells into objects, but if you just don't do that, it should work.
So let's say I want to 3D print this, right? So I made sure that I joined everything. Now let's just also analyze our edges, show edges. And I'm going to select all of these because I want to see. There are no naked edges, which is great. But now what I want to do, let me just ghost this real quickly. Okay, shaded. I am actually going to join all these. Now remember, joining and grouping are 2 different things. Beware. Joining is like fusing, right? It's like welding something. Don't confuse the 2. Grouping just means you group 2 things and you can move them around. So when something doesn't work, ask yourself, oh, did I group that thing? Ungroup it, or at least try to ungroup it. And sometimes that'll solve your issue. So let's join this. Oops.
What if you did a Boolean union instead of a join?
You could do that too. Let's do that. That's a good idea.
If the objects were not capped, we wouldn't have been able to join them, right? Or no?
Once again, it depends a little bit, but in general, let's see. Let's try it real quickly. So this is not capped. And let's say, for example, we make a sphere. Let's try to join these two, extrusion and the solid. Yeah. It wants it to join with another open surface. So now let's cap this. And now let's join these two. No, you'll want to use Boolean. Looks like Boolean union is better here. Boolean union, that'll work. So now we have one thing. Okay. Now, before I actually export this, here's something else I want you to think about just in general with your models. If you want these edges to be really hard, that's great, but there's a lot you can do to finesse your model. And one option is to fillet the edges. And let's say, for example, I want this just to be a little bit more nuanced. I like using the face edges because very often you want a fillet on all the edges of a single face. So I'm going to say face edges, pick this one, and it's going to select all the edges of that face. And let's hit preview. I'm going to zoom in a little and you can sort of see it's kind of telling me, it's showing me what it's going to do. And if you're happy with that, you say done. So I highly recommend you go to your model and sort of see, how can I make this just a little bit more finesse, like fillet a couple of edges, or, you know, yeah, just think about what is the final outcome. How do you want it to be printed out? Do you want all the edges to be really perpendicular and straight edged, or do you want to round some corners? There's also chamfer. So let's do that. Chamfer edge. This one, maybe chamfer is better here. Let's try that. You see it's a slightly different outcome. It depends on what you're modeling. And now I can do the bottom one as well. So spacebar, I'm gonna now choose this face. Let's do that one at 1 as well. Whoops. Something. Oh, okay. It's hooking onto those edges as well. So in this case, you see, we don't want that. So in this case, you would say chamfer edge, and I'm going to just select my edges separately. So if you run into an error like that, you're probably trying to chamfer something that won't accept a 1 radius. So now if we say done, now it's chamfered those. So these are just sort of small ways that you can improve your model, or like just, you know, create a bit more of a finessed and finished look. Okay, so I'm just going to delete these. And I'm going to also move this just to 0, 0. Okay, let's export this, but first let's just see how big this is, right? And we can talk about dimensions later, but you want to also just see, okay, what am I, 34 millimeters? That's very small. So I probably don't want this object to be that small. So I'm just going to delete that. Let's just make this a little bigger, right? Now here are all the curves. So curve, edit, select objects, curves. In this case, I'm just going to delete them. I don't want the curves in this file. Okay. So now let's just move this one more time from this point to 0. Okay. Let's see how this will print. Okay, now I'm going to say File, export, and you want to save it as an STL, stereolithography. OBJ works too, right, Jake, with the Prusa?
I don't think so, but 3MF will.
3MF?
Yeah.
Okay, well, let's stick to STL. So, okay. I usually don't mess around with this. Just say, okay. I never change any of these settings. Okay, now I'm going to go to my Prusa slicer, and I'm going to put a link in today's session page so that you can download the software. And I want you to familiarize yourself with the software a little bit. So I have a Mini. Okay, so how do you navigate? Left click is orbit. Right click is pan. This is your object. This is your preview, which we'll see in a minute. I have my printer set to original Prusa Mini, but the one that we have on the Medford campus is this one, the i3 MK3S. So let's just change it to that. So you see, it's a slightly bigger. I'll just show you the difference between these two printers. Let's go back to the home page. So this is the one that we have in Nolop. And then the one that I have mine set for is, it's just called a Mini. It's this one. So you can see it's just slightly smaller. But I have to say, for most applications, for most things that you might want to do, the Mini is great. It's about this big, the size of the bed. And I've been able to print a lot of stuff on it. And as you can see, it's $350. Pretty amazing. It's really a very good quality printer for that price. Okay, so you're going to make sure your printer is the Prusa i3 MK3S. And once again, I will do some screen grabs and put this online as well. Now, first let's import an object so we can actually see. So File, Import, and let's import our hourglass. And there it is. Okay, so a few things. This is a good orientation for the printer to print. Sometimes your model will come in a funky way. You see this icon here, place on face. So this is the face. Right now, the bottom of this object is on the face, but let's say for argument's sake, my model came in like this. Now, this is not a good way to print this model because you're going to need all kinds of supports here. You will as well if it's standing up, but this is much more complicated for the printer to print. So you want to find a face that's that has a lot of stability. And there's no way of like explaining that to you guys without you getting used to it a little bit more. But you'll quickly understand once you've printed one or two or three things, you're like, oh, this is the best way to print it. It's just sort of, So if I want to change that, I'm going to click on this place on face, and you'll see that all these white areas, whichever one I click on, it's going to place it on the face. So let's click on this one here, and I'm happy with that. I can move this object around. Let's say I wanted to print many of these. I can import, just delete this. I'll show you something that I was printing. I was printing a bunch of parts for let me just find my files. Is it under downloads? So I was printing out a bunch of files, right? And so I was sort of guessing how many of these can I fit on there. So I'm like, okay, I'm going to do this one, this one, this one, and I'll throw that in and throw that in. No, that one will be too much. Maybe that one. Oops. Okay, so I can shift click and import multiple STLs. So let's do that. they're going to come in all stacked on each other. I can move them away. I'm going to click in fresh air, move them separately, or I can click on here and it's going to automatically arrange them. See that? So this is a good example of, for example, this here. Let's just move this aside a little. That's a perfect example of Prusa not importing this in the best way. So this is a little button that I can put on top of a screw so that I can, instead of needing to use my fingers for the screw, I have a little thing that I put on top of the screw. So this I can see, let me just move this aside. It's hollow on the inside. And instead of printing it this way, I'm actually going to flip it so that it prints this way. This is going to be a better way for the printer to deal with that particular print. For the others, I don't see many issues in terms of, well, no, maybe this one, I don't know. Maybe I would do that instead. Jake, do you agree with that assessment?
Yeah. Actually, there's the big overhangs on the top now.
Oh, you're right. Yeah. So
So
maybe
on the back face. Oh yeah, that might work because it would just like slope up and then do the roof.
yes,
Or maybe, yeah.
this one. Actually, I wonder this one,
Yeah, I like that.
that would print the best, I think, because you can imagine the printer's going wah, 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 wah. So it has a lot of, it has a wall that it's building on. Whereas if I did this, let me just delete these ones so you can see. This is not a good placement at all, because now the printer has to build a whole wall inside here to support this edge. And do you guys kind of get the gist of this? Let me see, where are you? Yeah? Okay. So that's this icon here. Let's go back to Henley's file. Also, zoom in and out is just the scroll wheel. So let's import the hourglass again. Okay. If I wanted to print more than one, I can just Control C, Control V. So now I have two. Green means I have the model selected. Orange means it's not selected. So let's say I want to print two of these. Okay. Now let's look at settings. So I have the correct printer set. Print settings. And for now, just use this. I mean, there is an expert mode, but just stay with the, yeah, you can use the advanced version. So print settings. Here are some settings we can choose. So in general, I usually do 0.15 quality. Now, I've done a few tests between this and the detail and the ultra detail, and I don't see a huge difference in that. It depends on what PLA you're using too. But Jake, please jump in anytime if you have better recommendations than what I'm giving. There's 0.15 quality for these prints.
We do 0.2 like by default with most of the prints at NOAP. If you want higher quality, definitely go for it.
Yeah. You guys set this as the default?
Yeah. But since we're slicing our own models, and like using Prusa Slicer and delving into the settings a bit more, definitely pick a layer height that's what you want.
Yeah. I mean, for the size models that we're doing, let's go with 0.15. I feel like it's sort of in the middle. It's nice quality enough. Now the filament, we are going to be using generic PLA, but if you ever want to use something different, this is where you set it. As you can see, I tried carbon fiber. It was a huge disaster. I completely busted my nozzle. So if you do end up buying other filament, make sure you read up on it, like what are the settings, and there's a lot of information out there that I didn't read and I really regretted it. So, but we're just going to use generic PLA. And then supports. So this is important. This area here, we definitely need supports in this model. And what I usually do is I'll just say supports everywhere. And we're not going to slice just yet. Infill. Now this is another 15% is fine for an infill, and especially if it's for a model that you don't need it to like do anything or take a lot of resistance. Infill becomes important when you're making parts that need to function, right? That need to bear some load. For example, as part of this drawing machine, I have this V slot. I have like a slider, and there's going to be a motor attached to it. So that little part needs to have a bigger infill. That part needs to be quite sturdy. So the infill is what's inside. It's what holds the model together. You know, I'm not going to print. If I did 100% infill, that basically means everywhere where I see geometry, it's going to use plastic. That's a lot of PLA to print this. So 15, I think, is totally fine. Personally, I like using a brim. So what a brim is, it creates, actually, let me just do these settings and then I'm going to slice it and I'll show you the differences. So we have supports everywhere. Our infill is 15% and we have a brim. So let's slice. Takes a little bit. Actually, it's taking way longer than it usually does, but it's going. Okay, whoa. So you can see the green. Where is my little pop-up? Oh, there we go. So here it's telling me what everything is, right? So red is a solid infill. Orange is my external perimeter. And then the support material are all these green things here. So we're going to need quite a bit of support material for this model. 22 hours. Let's see. Okay. Let's go back to the model.
I wonder if you could get away with only putting support within like a cylinder that goes through the center of this model.
Yeah, maybe I should do that. So let's try that. So in this case, I'm going to say, well, I haven't done this in a while. Let me see. I think it's support enforcers only.
Mm-hmm.
And I click on this and then...
I think you can right click and then say add shape. Add support enforcer at the bottom, towards the bottom there.
Oh, here we
enforcer though, yeah.
Cylinder. And then I place this here and I do that. Hang on. Oh, I haven't done this in a while. How do I scale that?
Underneath the move button is the scale button on the left.
Oh, here we go. Thanks, Jake.
Mm-hmm.
Okay, it's... I would say you could get away with this. Just move this in here a little.
I'm also worried about that like really thin structure in the center, like breaking away whenever you break away your support material. It's like just something to be mindful of.
Mm-hmm. Yeah, because what's going to happen now, so now if we do this and we slice it, so this I'm still going to keep the brim, so let's slice that.
That's cool.
That should work better. And it should print much faster. Let's see what this gives us. Now it's 14 hours. See, that makes a huge difference. Let's go back to our model. Let's just delete this one. Let's just work with this one. So in this case, you want to use support enforcers. That's a better option than support everywhere. I have found for most of my models, the Prusa slicer does a pretty good job of just picking everywhere. But in a model like this, you might want to look into. So I'm glad we're using this because it kind of shows how you can set those settings for yourself. But so Henry, Jake has a good point here that this, when all these supports are going to come out, when you have to snap them off. Actually, I'm just going to fetch one of my 3D models so I can show you guys what those supports look like.
I know exactly what he's talking about, and yeah, I didn't really design this model with 3D printability in mind, but yeah, that's definitely something to be concerned about.
Yeah, that makes sense. Another option I'm thinking about for this part would be to split it in half and then print like the top and bottom face, like both on the build plate.
I see. Is there a way to do that in Prusa Slicer, like really easily?
Yeah, it's the bottom left button there on the toolbar on the right, on the left.
I see it.
It's, yeah.
All right. Awesome.
So I just wanted to show you guys this. So this is something I printed just yesterday. That's part of the machine, right? So you can see this is what's called the brim. Let me just switch off my background because I think it's hard to see. Okay, so this here is the brim. I like printing with a brim because every now and then my model will sort of lift up. What this does is just creates one little layer to hold down your print onto the bed, right? And it comes off very easy. So when your print is done, you just sort of snap this off, right? Now, and then this is support. See this here? And this comes off very easily. So I read online what a good way to remove support is to dip it into hot water and to start removing the parts in hot water, because sometimes it can be a little hard on your hands. You can also use a small, what is it called?
Pliers.
File or
I was thinking in Flemish. So, okay. So it's going to look messy for a while, but all this comes off. I'm just going to continue taking these off. And then for any kind of like screw holes, sometimes it will create these little things and they come out as well pretty easily. So you're just going to continue popping these off until you start seeing your model. Let me just, it's a perfect example of something that I would dip in water. Ooh. Okay, well, this will take a little longer than, but you can sort of see, right? I'm just pulling these parts off until I start seeing my part. Yeah. Okay, so that's that. Sometimes also you'll see that it comes out with these little, almost looks like silkwormy. That's just, you know, fuzz that you can just remove. Wow, that's a very strong. So you can see, you can just remove that. There's another support. I can just jam that out. Some people really enjoy this process and think it's very satisfying. I think it's a big pain, but it's necessary and you have to do it. But the hot water tip, that really works. Oh no, I have like PLA in my coffee now.
A little extra seasoning.
Yeah.
Nice little snack.
It's probably nicely melted into your coffee. So
This is the little button that I printed, and this is a tiny, tiny little brim, so I can just pull that off, and there it is. So, okay. what am I missing here? Oh, so then let's say I slice this. Boom, 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 boom. Let's say you're happy with the way it's sliced. The very last step is to export the G code. So G code is the language that the printer reads. There are a lot of different CNC machines. CNC stands for computer numerically controlled. So like a CNC milling machine or like the pen plotters that I've been building. A lot of these machines read G code, and G code is actually a very simple language. So let's export this G code and see what that looks like, right? You don't need to know this, but just for you, for your own, curiosity. So I exported that G code, and let's open that up in, I'm just going to open this in TextEdit so you can see what this looks like. So this G code was generated by this specific slicer, and it depends on what slicer you use. But all these values like M, that stands for movement. So, it says, okay, it's moving, X value is 200, Y is 200. Those are coordinates. Here's the Z coordinate. E is extrusion speed. So it tells you here it's going to extrude at 120 millimeters per second. You don't have to know all this stuff, but as you get into more advanced 3D modeling, and maybe at some point you want to build your own machines, or you come across other machines and something's not quite right, sometimes it's good to go into the G code and see what is something going on. So all of this is pretty much already programmed by Prusa. It's built into the software. You don't need to worry about it. But you see, they can also, they know that some people are going to open up this. So they say you don't change the E values below. If you do, you might damage the printer. So they're telling you, like, go forward at your own sort of, risk. The actual printing part is right here. So this is the G code that tells the printer what to do. So move from this. So the feed rate, this is the feed rate, and then say move to X position 109.595, and this is Y, and extrude. Move to this point, extrude. Move to this point, extrude. And then at some point here you can see, what is this? X, Y. I'm not sure what this is. Maybe Jake, maybe you know.
I think that's like a feed rate thing for the extruder.
Yes.
Like the F.
It's just going to change the feed rate here to maybe faster or slower. It looks like this is faster. Yeah, that's a slower feed rate, and for some reason it's deciding to speed up the feed rate, right?
It might actually be like the movement speed between points. Because if it's like a travel move instead of an extrusion move, it wants to do that faster to save time, because it's not actually affecting the part.
Exactly. Yeah. So I just wanted to show you guys that the code behind it is actually really simple. And you can see for that whole print, but it's very long. As you can see, every single movement in the machine is like written down, right? So this is what the machine sees and says, okay, go here, do this, go here, do that, go here, higher feed rate, go here, slower feed rate. So it's just telling the machine what to do. And that's the last step. And it's that G code that you then save on a USB stick, or you can email to someone, and that's going to print your model. And they're very small files, because it's just basically, it's kind of, it's a text file, right? It's just, it's much smaller file than a 3DM, which is the one that you save. That's the native file type from Rhino, right? Any questions so far? Because I want us to take a quick break. Jake, is there anything I missed with this?
Could you scroll through the layers in Prusa Slicer so that you can see it build up? There's like that bar on the center right.
Oh, here.
It allows you to sort of see exactly what the printer's going to do at each layer. And you can see it gets really thin in the middle there.
Oops. Here you can see the infill. So you see how it's not just printing the whole object, it's just creating enough of a support so that the structure, so that there's a structural integrity. And here you can see there's only this little part here, but as you go down, obviously you need more of those in order to hold up. And you can see this is how the printer is going to move, or the nozzle. What else can we show? That
I
might
was
be handy.
thinking about maybe splitting this part into like 2 parts.
Oh, you know, I haven't done much of that.
There's an easy way to do it in Prusa Slicer.
In
It's
where?
over in Prusa Slicer.
So where do I go for that?
In the slicing tab, not the G-code tab. Yeah.
Here? Oh.
No, like the cube instead of the layer cube in the bottom left. Yeah, like above your mouth. Yeah, that one.
Oh.
And then if you select the model,
Is it this one?
yeah,
Cut. Oh,
yeah, cut at layer height.
okay. Oh, so it's going to cut it right there. Okay, so perform cut.
Yeah,
Okay,
and then you could do a place on face.
that's true. Oops.
But then you'd have 2 parts and you'd have to like super glue them together or like design in some sort of connection mechanism. But this might print better.
This would be good if you have some kind of object that's too long for the bed, right? And you want to split it up and put it like this. So I haven't had to use that too much with my models because I usually print parts, but that's good to know. Thank you.
I think this would need less support, maybe.
Maybe, yeah. Yeah, because now we could just create a smaller little cylinder right there. And
Well,
maybe,
I don't think you'd need anything there.
oh, you're right. I don't need anything here.
The only hard part would be the underside of this like part that comes outwards, but
Here.
I think it could actually handle it. It might be a little droopy.
Let's say everywhere what it does. It's going to create all the way up, I think. Let's see what it does. Oh, no. You see, it's pretty good at usually figuring out. So it's saying, you know, be a good idea to have some support there. And look at that, 7 hours. But like Jake said, you're going to have to super glue this together.
Yeah, that won't look very good.
Yeah.
And then another option, you know, we split it like this, but you could have split it like this.
Let's try that.
You'd have to rotate the part and then do the split command after you rotate the part. But that could be interesting.
Rotate.
Or just place it on the side face.
Yeah, let's do that.
That's more precise.
And
yeah, and now split it.
Split it. You're saying split it exactly there?
Yeah, I think that could be cool. And then we'll see. I think that would actually make this center bit a lot stronger since it would be like
And then
entire strands of filament creating that center bit instead of like layers.
placing it like this.
Yeah, and then you might want support underneath those bridges or else they'll droop down in the middle, but that would be more surface area for you to super glue as well, which could be.
It's true.
Yeah, I like that.
Because then you're not messing around with, this is just a brim that tears off very easily. It's just a very thin little layer that you're going to be tearing off. It's going to just
And that won't snap either, that center bit.
snap. Yeah. So this is actually a good model for us to work with because I'm just going to stop my sharing because that kind of showed us all the different options, right? So these are the things to keep in mind when you're